This is the first question. Question says, length, mass, and temperature are SI-based quantities. State two other SI-based quantities. Now, what examiner did over here, he took away three basic quantities from you. And the list is not very long. There are only 7 basic quantities, out of which 2 we do not discuss in AS. So most common quantities left are just 2. So actually, there is no choice. One of the basic quantity is time.
Current. Okay. Yes.
Yes, and one is current, electric current. Normally, when we say current, only electric current comes to mind, but actually current means movement. Water current is also something. So acceleration of free fall G may be determined from an oscillating pendulum using this equation, where L is the length of the pendulum, T is the time period of the oscillation. In an experiment, the measured values for an oscillating pendulum are: length is 1.50 meter plus minus 2%, and time period is 2.48 plus minus 3%. Calculate the acceleration of free fall G. Now, for the first one, he's just giving you 1 mark because he's telling you the formula. All you need to do is just put the values in. So G will be, it is 4 times pi square, 4 times pi square, length is 1.50 divided by 2.48 square. So all you need to do is put everything in the calculator. So I do not have a scientific calculator over here, so you can just put in your calculator and find out the answer. But
Okay, sir.
5 divided by, so it is 9.6184. 9.6184 meter per second square. For the type of questions where we have to calculate errors and uncertainties and we don't know how many signal figures, we should actually round it off. The general method is that we round off everything to 2 signal figures. That is okay. But for these kind of questions, you should write down some extra significant figures as a record. But for the final answer that you present to the examiner, you say it is 9.6 over there. Okay, 6.2. Because he was giving you data in 3 significant figures, so you give your answer in 3 significant figures as well. Now, determine the percentage uncertainty in G. What is the rule for percentage uncertainty? If you remember from previous lecture, this is what I told you, that if this is a formula, A equals to BCM over D power N, these are all factors and this is the product. Percentage error of this should be sum of percentage error of all these, with power should be multiplied to the percentage error. So percentage error of A equals to percentage error of B, percentage error of C times M, because there was a power M on C, and percentage error of D times N because the power of D was N. Similarly, we have this situation and we have percentage errors of L and T, and we need the percentage error of G. So what will be the percentage of error of G? So percentage uncertainty in G equals to percentage uncertainty of L plus 2 times percentage uncertainty of T. Why did I do 2 multiplied it with 2? Because there was a square on T. Okay. So answer will be 2 times 3, which is 6 plus 2, 8%. So that means this answer that we have calculated, 9.6184, has an 8% uncertainty. Now examiner is asking for the absolute uncertainty. All we have to do is we have to find 8% of this thing. So I'm bringing my calculator back. Luckily, the answer is still there. I multiply this with 8 and then divide it with 100. So I get 0.769. 0.769. But remember, absolute uncertainty only has one significant figure. That is the rule for absolute uncertainty. And this was also discussed in the previous lecture that absolute uncertainty should always have one significant figure. So we have to round it off to one significant figure. It will become 0.8. So absolute uncertainty is 0. In this question, he did not ask you to write the final answer, but normally what he does is he gives you a chance to write down the answer like this. So what do we do? First, we have to round off the error to single significant figure, that is 0.8. And that lets us know that we are supposed to round off the quantity in one decimal place. The final quantity will be 9.6. He didn't do that in this question, but he normally does that in all other questions.